So we've seen that we can use the integer type to convert, for example, in this case, an integer to a double by using the double value method that belongs to the integer type. We can do the reverse of that. So let's say we start off with a double, and notice I'm using the box type, the class type here. Okay. If I wanted to convert that to an integer, I can say int number as int equals, and I can use number. And again, there are various methods that belong to the double class that allow me to convert it to other types. So in this case, I can convert it to an integer, but similarly, I could convert it to a float or a byte, a long, or even to a string. So let's do that. Okay. Now the thing we need to be aware of is if we print out our number as integer, okay, we lose the decimal point. So let's just run that. And there's our output 4, even though this would, if we were rounding, we'd round up. Okay. So if we want to do rounding instead, using int value might not necessarily be the correct approach. Okay, so let's take that away for now. It does have its place, obviously. If you don't care about the value after the decimal point, then this is a great way of doing the conversion. If we want to do rounding, however, we can make use of the math class. And yes, it is math and not maths, which is slightly unfortunate, but I presume the developers of Java may have been American. So we've got math. We can ask the math class for various different things, and you'll see there are a lot of mathematic operations that are available to us. So we're just going to do a little bit of essentially doing some conversion of a data type. But we can also, for example, find the absolute values. If you've got something that might be negative, you can make sure it's positive. You've got sine, cosine, tan. Plenty of other mathematical operations, finding the minimum and the maximum of a value, and so on. But the one we're interested in today is the round method. Okay. The thing to be aware of here is that if we pass in a float to the round method, we'll get an integer back, and if we pass in a double, we'll get a long back. It may let us store a double as an integer. We can try that, but it's probably better to make sure that because we might not necessarily know what the number is, we don't want to find out that it actually exceeds the maximum value of an integer. So we probably want to be on the safe side. We'll try it with an int, see if it allows us to do it, but then we should really use a long. So math.round, we could pass in our number. We could say int rounded number equals. No, it's not going to allow us to do it anyway, which I think is good. So we'll just declare that as a long integer. And therefore, if we then print out our rounded number, we should find out that we get a 5 out instead of a 4. Okay. So we can convert between data types with the various methods that belong to the numeric classes. So integer, double. Again, you note the use of a capital to denote the class type or the boxed type. So in this case, number is an object and not a primitive. If we were to declare it with a lowercase d, it would be a primitive. And in this case, that's fine because we're not using for example, the integer value. Okay, so with a primitive, I can't do number dot int value. But if I make this the class type, I can say number dot int value, and I can get that integer out of it. Okay, so just be aware of the difference there. If you don't need to use any of the methods that belong to the numeric type, then you're probably better sticking with the primitive type. And again, IntelliJ is trying to help me here, and it's saying, well, don't use the wrapper type, use a primitive, and I can click that, and it will change the capital D to a D. And then for mathematical operations, including rounding, particularly for rounding, you can use maths round method.